Now, in today's video, we can have to discuss about what we call as the measures of the dispersion. So, before you go for this lesson, just have to go through the lesson we discussed about the measures of the central tendency. That is, we talked about the mean, mode, as well as the median, because that would be the fundamental in the understanding of the measures of the dispersion. So keep that in mind. So we talked about two types of the data. We have what we call as the qualitative data. We have what we call as qualitative data. And what is the qualitative data? This is the data that defines the quality or characteristics of an object, or should be of the variables, by the way. So what are the examples of the qualitative actual data? We have the appearance. It should be that we have the appearance, that is in terms of the color. So we can actually classify variables or objects in terms of the way they are looking. Then we have what we call as the status. So on the status, it's either someone can be rich or poor or media, can be rich or poor or middle. And we have also the status in terms of a soil being fertile or infertile. That is also part of the status. And we also have the gender. That is another example of the qualitative data. Then we also have the preferences. So these are the examples of the qualitative data you should have to get. So try to come up with 4 or 5 other examples of the qualitative data, and I want to see them in the comment section below. And we also talked about what we call as the quantitative data. So we also talked about what we call as the quantitative data. So what is the quantitative data? This is the data that defines the numerical values. In other words, these are the values that can be measured. We have the examples like, let's say, the mass of the object. We can be able to measure the mass of the object. We can have, let's say, length. This is also part of the quantitative. And we have, let's say, the amount of something. Let's say amount. That should be that. And we have several examples of the quantitative data. So try to come up with at least 4 or 5 actually examples of the quantitative data. And I want to see them in the comment section below. Now, how do we analyze the quantitative data? So that's the point of interest in the video. So last time we talked about the analysis of the quantitative data using the measures of the central tendency. So measures of the central tendency. So that is the measures of the central tendency. So measures of the central should be tendency. So that is. So on the measures of the central tendency, we talked about, we talked about the mode. We talked about, let's say, the median. And we also talked about the should be mean. Of which we said the measures of the central tendency. This defines the centralness or the concentrative of the data that we have. So that's the measures of the central tendency. It actually discusses the centralness or the concentrative of the given data. That is what we call as the central tendency. So the parameters that describes about the measures of the central tendency, we have the mode, and that we defined as to be the most frequent occurring values. And we also talked about the median, that is the middle value, and we also talked about the mean, that is the average of the given set of the data. So in case you missed this, just have to go through my video playlist on the YouTube channel, Facebook, as well as the Instagram. You come across all these things. And also, that should be a TikTok. You come across all these things. Just have to search GB Analytical School of Science. You come across all these things. And apart from the measures of the central tendency, the quantitative data can also be analyzed using what we call as the measures of the dispersion. So this video, much of it discuss about the measures of the dispersion. So measures of the dispersion. So that is the measures of dispersion. So that is the measures of the dispersion. So what is the dispersion? Dispersion, this is simply means as, the dispersion simply means the spreadness of something. That is what we call as the dispersion. So on the measures of the dispersion, the point of interest is to look at how the data values are spreaded, with respect to the center of the data, that is the mean. In other words, the measures of the dispersion tries to define the spreadness of the actually given data about the mean. That is what we get as the measures of the dispersion. It talks about the spreadness of the values or the data values with respect to the mean. That's what we get as the measures of the dispersion. So what are the actually examples of the parameters that discusses or that explains the spreadness of the given data? We have what we call as the range. So on the measures of the dispersion, we should be talking about the range, and we should also be talking about the mean deviation. So we'll be talking about the mean deviation as one of the components of the measures of the dispersion. And we also have another important parameter, which is given as the variance. So we'll be talking about what is the variance at the end of the day. And we also have the final one, which is given as the standard deviation. So we'll be talking about all these things that is the standard deviation. So these are the actually components of the measures of the dispersion. That is the range. We have the mean deviation, of variance, as well as the actually standard deviation. So these are the components that discusses the spreadness of the given particular actually data. So mind you, we have the grouped data as well as the ungrouped data, of which you will be checking all these things. Is actually will be using the grouped data and also ungrouped data in the understanding of all these things. But make sure that you have the full knowledge about the measures of the central data. So that is the mean, how we can have the mean for the grouped and the grouped data, how we can have the median for the grouped and the grouped data, and also the aspect of the model. So we'll be we need to be much familiarize ourselves with those actually things like that. So let's start with actually the range. So this video we just have to discuss about the range as well as the mean deviation. The next videos will be talking about the variance and the actually standard deviation. So let's start with the range. So what do you think a range is? Now if we say a range, a range that simply means the difference between the highest value and the lowest value in the given set of the data. That is what we call as the range. So in this case, the range is given as the highest value minus the lowest value. This is the formula for the range, and that's how we actually calculate the range. So let's start with how we can have the range for actually any grouped data. That is for ungrouped data. Let's say we have the grouped data, which is given as 2 should be 20. Let's say we have 5, 10, 60. Let's say we have 60. We have 2, and let's say 100 should be 80 as well as the 100. So how do you think is the range of the data? So first thing, we should have to arrange the data in ascending order. That's the simplest way to. So we have 2, that's the lowest value. We have just have to identify what is the actually lowest value. So the lowest value of the data set is given as 2. And how about the highest value in the given data set? We have it as 100. So what is the range? Now the range is given as the highest value minus the lowest value. So in this case we'll have it as 100 minus 2, which is given as 82. Should be 88. Should be 98 rather. So that is the range. So we have it as 98. And we also have, let's say if we have this given data, let's say if we have something about, let's say 50, let's say we have 100, we have 60, and let's say we have 70, and we have, let's say 40, let's say 25. So how do you think is the range of the data? So the range will be given as the highest value minus the lowest value. That is the point of interest. And what is the highest value? Highest value is given as 100. And what is the lowest value? We have it as 25. So what do you think would be the range? So in this case, we'll have it as 75. So that is the range. And basically, you know, the data which is more spread or which is more dispersed, you know, it possesses the more range. So that's how you can have to define, or you can have to interpret the range. So the range itself shows how the data is actually dispersed. So if the range is actually, if the range is, the larger the range, the more dispersed, you know, the data is. So that's how you can actually, that's how you can differentiate, you know, the given set of the data in terms of the range. Let's say if we have the following actually set of the data values. Let's say if we have the data value of the set A, which is given as 2, 10, 5, 60, and let's say 70. And we have the set of the data values given as B. Let's say it is given as 20. We have 18, 19, let's say we have 60, and we have, let's say 20. And we have the another data set given as C. Let's say if we have it as, there should be about, let's say 40. We have 20, 15, let's say 10. There should be 12. Let's say we have 14. So in this case, which data is more dispersed? So what do you think will be that? So in this case, you should have to, you know, differentiate those using, in terms of using their respective actually should be ranges. So in this case, we'll have the range of the data set A, you calculate that one. The range of the data set B, you calculate that one. And the range for the data set C, will have that one. So the one that will possess the largest range will be the one which is more dispersed. So that's the information in which the range actually gives, and therefore the given set of the data. How about if it is a grouped data? How about if it is grouped data? How do you think the range can be obtained? So let's say we have the grouped data, you know, which is given as, should be, we have, let's say, the data that shows the grades. Let me just have to have it as the class, you know, the class intervals, and we have their respective frequencies like this. Let's say the first class is given as 40 to 49. Let's say we have that, and the frequency is given as should be 3. And we have 50 to, let's say, 59, and the frequency is given as 5. And we have 60 to 69, and the frequency is given as 6. And we have it as 70 to 79, and the frequency is given as 9. 80 to 89, and the frequency is given as 8. And finally, let's say we have 90 to 100, and the frequency is given as 7. So how do you think we can have the range for the grouped data? So in this case, we should have to consider the lowest actually a group. So this is the lowest group, or this is the lowest class. So the lowest class is given as 40 to 59, should be 40 to 49. So have it as 40 to 49. Then we are going to have the class, I should say the midpoint of that particular class. So mind you, the midpoint of the class or the interval, it is given as, the upper value and plus the lower value divided by 2. That is the formula for the midpoint for the given class. So in that case, what is the upper value? Upper value is given as 49. And plus what is the lower value? We have it as 40. And then divide by 2. So what do you think would be that one? So have it as 89 divided by 2. So what is 89 divided by 2? What would be that? So 89 divided by 2. That is given as, should be 445. Should be 44.5. So that is how you should have it. Then we should have to consider. The largest class. So what do you think is the largest? So this is the largest class. So the largest class is given as 90 to 100. And we should have the midpoint of the class. That is 100 plus 90 divided by 2, which is given as 190 divided by 2. We have it as 95. So in this case, we have that. Now how do you think it will be the length if that is the case? Now the length will be given as, the midpoint for the largest class, which is given as 95 minus the lowest class, which is given as 4.5. So this is how you should have it. So 95 minus 4.5, that will be given as 50.5. So this is how you should have to calculate the length of the group D data, like that. That is. And how about, let's say if we have this data and try to have the length of the data. Let's say we have it as, should be the class. We have the classes like that, and this is the frequency. Should be that. We have the first class, which is 1 to 5, and the frequency is given as should be 2. We have 6 to actually 10. That is given as 3. Then we have should be 11 to 15. The frequency is given as 16. Then we have 16 to 20, and the frequency is given as 4. And we have 21 to should be 25, and the frequency is given as should be 1. So how do you think would be the mean, should be the length of this actually grouped data? So try to have that at your own time. So let's now have to discuss about the mean deviation. So what do you think is the mean deviation? So mean deviation, this is the average of, this is said to be the average of the deviations from the mean. That is what we get as the actually mean deviation. That is said to be the average of the deviations from the mean. And basically mean deviation, it is given as the summation of, it is given as the summation of the absolute values of what we get as, x minus should be x bar and divided by should be n, where n is the same as the summation of the frequency. So this is the formula for the mean deviation. So what do you think is x minus x bar? So the difference between the data value and the mean is said to be the deviation from the mean. So that is deviation from the mean. Deviation from the mean. That is what we get as the actually x minus x bar. And what is the deviation from the mean? Deviation from the mean. This is the value that shows you actually if we say deviation from the mean, this is the value that shows how far is a given data is away from the mean of the data, that is deviation from the mean. That is how we should have to get it, how far a given actually a data is away from the given set of the actually away from the mean of the data. That is what we call it as the deviation from the mean. So let's see, appreciate that one in the following actual case. Let's say we have the data values, which is given as 6, and let's say we have 7, and now we have 10, we have 12, we have 13, we have 4, and also 8, and finally we have it as 12. So we should have what we call as the mean deviation of the data. So how do you think the mean deviation will be calculated? So summation of the x bar, actually x minus x bar, and which is divided by the summation of the frequency. In other words, how many values are here. That is. Now the first thing, we should have to calculate the mean of the data. So what is the formula for the mean? The mean is given as the summation of the values, and that is divided by summation of the frequency. So how many values are here? So summation of the x, or summation of the values, is given as, it should be, we have 6 plus 7, and plus 10 plus 12 plus 13 plus 4 plus 8 and plus 12. We'll have it as 70. We'll have it as 72. And we have about 8 values. We'll have it as that. So we have it as 72. Then the summation of the frequency, we have it as 8. Therefore, the mean, which is x bar, it is given as 72 divided by 8. So what do you think 72 divided by 8 is? So have it as 9. So that is the mean of the data, like that. Then we should have to present the table. In this case, we have the data value, which is x, and we'll have the mean like that, and we'll have that of x minus x bar like that, and we'll have the absolute value of x minus x bar. Should be x minus x bar. Should be that. Now we have the first data value that it can be given as 6. So we have 6. Let me just have to eliminate this. And by the way, mean is given as 9, so just have to get it away as well to create some spaces. Like that. So we have the first value, which is given as 6. We'll have 6 here. And the mean is given as 9. Then we'll have 6 minus 9, which is given as -3. And I'll have absolute value of -3, that is given as the +3. And we have 7 minus 9, that is given as -2. And what is the absolute value of -2? We have it as +2. And we have 10. The mean remains the same, which is 9, and the 10 minus 9, which is given as 1. And what is the absolute value of 1? That is +1. And now we have 12. And the 12 minus 9, that is given as 3. And what is the absolute value of 3? That is given as 3. And we have 13. So 13 minus 3. What would be that? So it should be 13 minus 9. That is given as 4. So absolute value of 4 is given as, should be given as 4. Then we have 8. That should be 4. Like that. And 4 minus 9, that is given as -5. So what is the absolute value of -5? We have it as 5. And we have 8. And that is 8 minus 9, that is given as the -1, and the absolute value is given as +1. So by the way, absolute value, it is the same as the positive value Then we have 12. So 12 minus 9, that is given as, should be 3 as well. And the 3, what is its absolute value? We have it as 3. So that is. Then from there we should have to from there we should have to have the summation of this column. So that is 3 plus 2, that is 5, and plus 1, that is 6, and plus 3, that is 9, and plus 4, that is 13, and 13 plus 5, that is 18, and 18 plus 1, that is 19, and 19 plus 3, that is given as 22. So that is 22. We'll have that. We have it as 22. Then we'll have the summation of, of course this column is already given as, should be 8. So that is given as 8. Now we can be able to have, so should be that. So in this case, the mean deviation, according to the formula, mean deviation will now be given as, should be 22 divided by 8, which is given as 22 divided by 8, that is given as 2.75. So this is what we get as the mean deviation. So basically mean deviation, you just have to show on average how far the given set of the data values are from the mean of the data. That's how you can have to understand about the mean deviation. So just have to show us on average how far each value is, how far the values are from the mean of the data. That is what we get as the mean deviation. So we understand that on the given set of the data, we actually calculated that the mean, which is x bar, is given as, should be 9. So let's try to present that one on the number line and see and appreciate the work or the principles behind the mean deviation, or should be deviations from the mean and the mean deviation. So always, let's say the center of the number line is given as, should be x bar, which is given as 9. And we had the data values like 6, we had 7, we had, let's say, 10, we had 12, we had 13, should be that, and we had 4, and we had 8, and we had 12, like that. So in this case, the principles behind, or the understanding of the deviations from the mean, entails that this is the center of the data that we have. So how far 6 is from the mean, you can see that 6 is actually located towards the left of 9, because 6 is less than 9. So it is about some steps given as, should be, let's say 3. So it is about some steps given as 3. So it means 6 is located about 3 steps from the mean towards the left. No wonder the deviation from the mean for the 6 was given as -3, because it is located to the left of, should be 9. And likewise, if you take an example of, let's say, a number 12, it's greater than 9, so it is located to the right hand side of 9. Let's say this is where the 12 is. So in this case, how far 12 is from the actual mean, which is given as 9, you can see that it is about 3 steps reaching up to a 12. So it can be that. So deviations from the mean, shows how far the data value is from the mean. That is deviation from the, actually that's a deviation from the mean. Now on the context of the mean deviation, it shows on average. We understand that each value has to be some steps far away from the mean, but on average, how far the values are from the mean. So that's the mean deviation. In other words, it is the average of the deviations from the mean for the given set of the data. So that's how you should have to understand about actually mean deviation in that case. And how about, let's say, if we have this data and calculate the mean deviation. Let's say we have the given set of the data which is given as, let's say, 20, let's say 60, we have 40, then let's say we should have 25, let's say 26, like that, and we should have, let's say, 8. So try to have the mean deviation. Let's say if we have something about, let's say it should be 12, should be 20, should be 16, should be 4, and let's say 70 and 80. Try to have that. And also try this question. Given that we have the set of the data which is given as, let's say, 2m, 5, let's say 6m, and let's say 7m. Let's say we have this kind of a case. Now, assuming that this data has the mean deviation given as, let's say, should be 5. So what do you think is the value of m, if that is the case? Try to have that. And let's say we have the set of the data which is given as, let's say, 5 minus q, let's say 6q, 7, and also 20. And given that the data has the mean deviation of, let's say, 10. So what do you think is the value of q, if that is the case? So try to have that one. And how do you think the mean deviation for the grouped data can be calculated? So how do you think the mean deviation for the grouped data can be calculated? Let's say we have the grouped data which is given as, we have the classes, we have the frequency like this. Let's say that is the case. And we have the first class which is 10 to 20, and let's say it should be 10 to 20, and what is the frequency? We have it as, let's say, 2. And we have 20 to 30, and what is the frequency? We have it as 3. And we have, let's say, 30 to 40, and let's say the frequency is given as 8. And we have, let's say, 50, should be 40 to 50, should be that, 40 to 50. What is the frequency? Let's say we have it as 3. So, and we also have, let's say, 50 to 60, and let's say the frequency is given as should be 8. So how do you think we can have, how do you think we can have the mean deviation for the data? So in this case, since this is the grouped data, of course the principle remains the same. Have the mean deviation formula that will be given as the summation of, now instead of just having x, we'll have it as x subscript m, where this one shows should be the midpoint of the class minus the x bar, which is the mean, and divide by the summation of the frequency, like that. So that will be the only difference. So in this case, we'll have to first of all calculate the mean of the data. Now you should have to understand, you should have to recall about how we calculate the mean of the grouped data. So you should have to go through that one. In case you missed that one, just have to go through my video playlist to come across all these things. So the mean for the grouped data, which is x bar, is given as the summation of the frequency times the midpoints divided by the summation of the frequency. So this is the formula for the mean of the grouped data. So as the formula itself suggests, we need to include another column for the midpoints. We'll have the column for the actual midpoints, and also have the column for the frequency times the midpoints. It should be that. So in this case, we'll have, what is the midpoint for this case? So we have 10 plus 20, that is 30, divided by 2, we have it as 15. And 15 times 2, that is given as 30, like that. And we have 20 plus 30, that is 50, and 50 divided by 2, we have 25. 25 times 3, that is 75. should be 25. We have here 75. And how about here? 30 plus 4, that is 70. Divided by 2, we have it as 35. So 8 times 35, that is 280. And we have 40 plus 50, that is 90. Divided by 2, that is 45. And 45 times 3, that is 135. So have that on. And we have 50 plus 60. So 50 plus 60, what would be that? 110 divided by 2, that is 55. And 8 times 55 times 8, that should be, that is 440. So have that as that. And from there, according to, as the formula itself suggests, you should have to understand that we'll have the summation of the frequency that will be given as, should be 2 plus 4 should be 2 plus 3, that is 5, and 5 plus 8, that is given as, and there should be 13. 13 plus 2, that is 13 plus 6, that is 16. 16 plus 8, 16 plus 8, that is 24. So have here given as 24. And we'll have the summation of fxm, that is. So what would be that? So have 30 plus should be 75, and plus 280, and plus 135, like that, and plus 440. So that would be given as, should be 96. Now the mean will be calculated as 96 divided by 24. So what would be that one? Divided by 24, we'll have it as 40. So that is the mean of the grouped data, as you can see. Then from there we can be able to have the mean deviation. And I will just have to, let me eliminate this column such that, but there is a need of including the new column that will actually help us to express everything properly in that way. So the mean is given as 40, which is okay with us. So in that way, now we'll have in this case we'll have, now it has been given as, now we should have the x bar, which is the mean. We have it as 40. So in all cases, mean remains the same, given as 40, given as 40, given as 40, like that. And we need to have a midpoint, which is, since this is the grouped data, minus the mean, which is that one, like that one, and we'll have the absolute value of that one. So try to complete this on your own. And how about, let's say, if we have this information, and also try to have the mean deviation if that is the case. Let's say if we have the data which is given us, and there should be, let's say, 0 to, let's say, 100. Let's say that is the case, 0 to 100, and those frequencies given us for, and 100 to 200, whose frequencies given as 8. And let's say 200 to 300, whose frequencies given as 9. 300 to 400, let's say the frequency is given as 10. And let's say 400 to 500, the frequency is given as, should be 7. Let's say 500 to 600, let's say the frequency is given as 10. Let me just have, should be, let's say we have 4, 8, 9, 10, have 7, let's say 5. and let's say 600 to 700, and let's say the frequency is given as 4, and likewise 700 to 800, and the frequency is given as 3. So try to have the actually mean deviation for this data in that way. So sometimes you can also be given, ungrouped data, which you have to present it in a grouped data. Then you should have to calculate the mean deviation. Let's say we have this data. Let's say we have 17, and we have, let's say, 5, then we have 22, we have 18, we have 25, we have 29, like that. We have 17, we have 15, and also we have, let's say, 12, we have 21, like that. We have 14, we have, let's say, 18, we have 19, 22, 11, 7, let's say 16, 24. We have 9, that is, we have 23, like that one. We have 27, let's say 16, 13, and finally we have it as 8. So the question says that we should have the mean deviation for this data. As you can see, the data is too huge, so the easiest way is to group the data. Now we should have to group the data into 5 groups. So you should have it into 5 groups, like that one, and starting from 5 to 9. So that's the starting, actually, that is the starting class, and 5 to 9, then 10 to 14, then keep on going. So how do you think you can create the frequency table? Then you should have to calculate the mean deviation for this case. So that's why I was saying you should have to make sure that you understand about the concept of the measures of the central tendency, because as you can see here, there is need of understanding about how to create the frequency table if you have been given the data. So that's a very important thing for you to understand about. So write that one. Now, how do you think if we have, let's say, this data as well? Let's say if we have this data given as 2, let me just have it as this. Now, how do you think if we can have this data? Let's say we have, these are the x values, that is the data values, and this is the frequency. Let's say we have a data value which is given 25, and the frequency is given as 1. 24, the frequency is given as 2. 23, the frequency is given as 4. 22, the frequency is given as 2. 21, the frequency is given as, let's say, 0. And the 20, the frequency is given as 3. So try to have, the mean deviation for the data like that. And also, how do you think you can have this as well? Let's say if we can have this kind of a case. Let's say we have the same way data values, that is given as 5, 4, 3, 2, 1, and the frequencies are given as, let's say, 2, 3, there should be 5, 6, let's say 4. So try that one. And let's say we have also the data value which is given as, let's say, have the frequency. Let's say we have 2n plus 5, the frequency is given as 6. Let's say we have 7, the frequency is given as, let's say, 10. We have, let's say, 6, the frequency is given as, let's say, 2. We have 10, the frequency is given as, let's say, 5. And we have, let's say, 6, the frequency is given as, let's say, should be 16, the frequency is given as, let's say, 20. And given that the mean deviation of the data is given as, let's say, 15, what do you think is the value of n if that is the case? So try to have such kind of a case. Thank you.